inequalities in one variable. So here's what we're going to do. We're going to start off talking about some notation, all right? So what I'm going to do is I'm going to set up a little grid for you, and we're going to fill these in these little boxes and see how these things relate to each other in terms of inequalities and notations. So first one is I'm going to give you an interval. Okay, then we're going to take that interval and we're going to transform it into an inequality. We're going to take that inequality and we're going to ask ourselves whether or not this inequality is what's known as bounded or unbounded. Kind of fit that in there. And then finally, we're going to do a number line graph. How it all relates to the number line. So the idea here is to be able to relate all four of these things and get information out of it. I think you've seen most of this before, with the exception of the way that we deal with intervals and inequalities. So here's an example, right? First one is, I'm going to give you the interval, -4, 3, and I'm going to put a bracket there. So I have a parenthesis, and I have a bracket. Probably you've never seen that before. You've probably related the parenthesis to what's known as an open circle, and you've probably seen the bracket, which relates to a closed circle. You guys have seen these on the number line, open circles and closed circles, right? Okay, so parenthesis, we've kind of graduated into parentheses and brackets now. So parenthesis means that we do not include that point. Bracket means that we do. Okay, so this is an interval right here. The interval, think about the number line picture in your brain. -4 to 3, okay? Give me a number that's in that interval. Yeah, start it up. Huh? 2. Who agrees? Is 2 in that interval? Yeah, give me another one in that interval. -1. Hands up, you agree? Okay, give me one that's not in that interval. Yeah. 4. 4 is definitely not in the interval. Good? Okay, yeah, another one. Okay, seems like, oh, good. Seems like this is making sense. How do I take this information that's an interval, and how do I write it in terms of an inequality? Any thoughts out there? Jeff, what do you think?
I think it would be -4.
Yep.
And you put basically, -4 is less than.
Uh-huh. We'll use x.
X.
Mm-hmm.
Which is less than or equal to.
Yeah, you're absolutely correct. Okay, so the thing I want to make note of here is that he associates the parenthesis with strictly less than, and he associates the bracket with less than or equal to. That's how we're going to denote these things when we're talking about intervals, all right? All right, now, ask yourself this, okay? Do you think that this particular interval is what's known as something that is bounded, like it's in bounds, or it's unbounded, which means it goes on forever and ever? What do you think? Yeah, this is what we call a bounded interval. Right? It's bounded. It's got a start, it's got an end. I can point to it. Okay? Now, how do we do this on a number line? How do we transform all this information on a number line? Here is how I want the number lines to look. Okay? I need 3 pieces of information on that number line. Can you give me 2 of the pieces of information that I'm going to need? Yeah, we got Paige. A -4 and a 3. Good. Now, it is very important that you set up your number line in the same way a number line is actually written. Okay? So, -4 is over here. There's a 3 over there. What is the third piece of information I'm going to require on every number line? Connor, what do you think it's going to be? 0. Okay, that's it. Those are the 3 things that I need. Okay? I need a 0 in there. So there we go. 0 right there. Now, I'm going to take my information and put it on my number line. I'm going to get -4. I'm going to get a 3. I'm going to get the space in between. And I like that just like that to denote that the answers, my solution, my set of solutions, any of my numbers can fall anywhere between -4 and 3. 3 is a member of the solution set. -4 is not because of that parentheses. How do you feel about that? Good? Is this somewhat familiar? Kind of? Okay, good. Let me give you another one. How would you denote this? -1, comma, infinity, comma, parenthesis. Now, before you do that, why did I not put a bracket around the infinity sign? Why did I not put a closed bracket? What do you think, Megan? Yeah. Yeah. That doesn't happen, right? So whenever we're dealing with infinities, it's always guaranteed to be a parenthesis, not a bracket. Okay. All right. Inequalities. There's 2 ways you can represent this. Give me one of the ways you can represent this for an inequality. Steven, what do you think, dude?
-1 is less than x.
-1 is less than x. I'm going to just stop you right there. Is that true?
Yeah.
Okay. Is that, who agrees with this? Hands up if you agree with that statement right there. Negative 1 is less than x. Okay. Is there another way I could say this? Mm-hmm. X is greater, right? Are both of those the same? Yeah, those both saying the same thing, right? Which one should we use? Why? What do you think? Because the other number is infinity, and infinity is to the right of negative 1, I guess? That makes sense, right? Both of those are logically equivalent, right? I think you're going to find it easier if you represent inequalities with your variables on the left-hand side. We'll talk about that in a minute. Okay, bounded or unbounded? What do you think? Unbounded. Yeah, this is unbounded, right? All right, so in this particular case, we're going to need number. We're going to need negative 1. We're going to need 0. And we're going to need a parenthesis. And notice the parenthesis is sort of opening up to the direction of where I'm going. So infinity is to the right. So that's my solution set. What do you guys think? Good, bad, or ugly? Good. Good. Sweet. Okay. You with me? Let's do 2 more. Let me give you this one. Bracket 0, comma 5 bracket. All right. Let's fly through this one. Give me the inequality. Just spit it out. 0 less than or equal to x, less than or equal to 5. Bounded or unbounded? Bounded. Very good. And picture. What are the pieces of information I need? 0, 5, bracket, bracket, space in the middle. How do you feel? Good? Okay, let me give you, what about this one? What would you do with this one? Talk to your neighbor about this one. Ooh. Yeah, my infinities are 2 zeros right next to the numbers, right? Okay. So here we go. So my inequality for this, right? We can put all real numbers for this. I wouldn't say you could have anything. You could say negative infinity less than x less than infinity if you really wanted to. Bounded or unbounded? Definitely unbounded, right? Okay. Anybody have anybody? Here's your number line. Here's 0, right? What is this going to look like?
You're just going to have 2 arrows and everything highlighted.
Parentheses, parentheses, and then...
Parentheses, yeah, okay. Parentheses, parentheses, everything, arrow that way, everything, arrow that way. So basically, we are talking about the entire number line. Does that make sense? Does that help you? Tommy? Yeah? That's a great question. Very good question. Okay, so you on board with being able to take an interval, translate it into an inequality, figure out whether that inequality is bounded or unbounded, and then translate that to a picture on a number line? Does that sound good? Everybody good with that skill? Set to go? All right, let's talk about properties of inequalities. And today, we're going to talk about 4 of them. I'm pretty sure you're familiar with at least the first one and the last one. Okay, so 1, 2, 3, 4. First one is the transitive property. Yeah. Raise your hand if you've been in geometry before. Or in algebra 1. Right, this comes up a lot, okay? Transitive, what do we know about transitivity? It's like when, oh, bummer. Happened. Is this the first? Nah, don't worry about it. Nah, we're good. How'd I do that? I don't know. Magic. Just as what? A's got less than C. Transitivity. There it is. Of inequalities. Yeah. X is greater than, less Let me start you off. A is less than B.
Okay. C is less than D.
Yeah.
A plus C is less than B plus D.
Yeah. Wait, what's your last part there?
A plus C is less than C.
Yeah, very good. B plus D. Yeah, so smallers, right? The sum of the smallers is less than the sum of the largers. How about that? Right? There's the English way of saying it. Does that make sense? Okay. Yeah. All right, so addition property of inequality. Now, next one, my favorite one, the one that we use all the time in solving these things, the addition of constant. So let me start you off if you want to take a guess at it. A is less than B. Two is less than 5, right? Okay, add 1 to both of those statements. What do you get? Okay, transpose it into this.
A plus 1 is less than
Don't use numbers, let's use variables. It has to be.
Less than B plus.
There you go, right? We use that all the time when we solve these things, but we don't even realize that that's what we're doing, right? We use it all the time. We use it forwards and backwards. And the last one is the multiplication, right? Now, what's the general rule here when we're in inequalities and we're doing multiplication or dividing by a certain type of a number? Yeah, what do you think? Yeah, okay. So we have two options here, right? So let's say that C is greater than 0. What's another way of representing C is greater than 0? What types of numbers are those? If it's guaranteed to be greater than 0, what do you know about it? It's a positive number, right? Okay. So that being the case then, okay, A is less than B, then we can say A times C is less than B times C because I'm guaranteed that my C is greater than 0. So far, so good? Okay. Now, what happens if our C, our constant there, is sort of less than 0? What types of numbers are less than 0? Negative. Those are negatives, right? Yeah. Another way of saying negative numbers. So, if I know A is less than B, that implies what? Greater than B times C. Now, what they don't tell you is that this also works when dividing, too, because dividing is just multiplication and inverse. So when you are dividing by a negative number, this rule also holds up. So these are our 4 properties. We use these when we're dealing with inequalities. So far, so good? Yes. Feeling good? Questions, comments, concerns? Good? All right, sweet. Let's get into the meat of this thing here, right? We're going to solve linear inequalities. Next idea here. All right, so let's practice one. Let me give you this one. How about straight up basic here? A. 5x minus 7 is greater than 3x plus 9. Okay, while we solve this, let's try and relate back to which property we're actually using here. All right. So now it's an inequality. It looks kind of like a what? Looks kind of like an equation, right? So we're going to do pretty much follow the same standard inverse operations that we'd normally do. Any suggestions or ideas out there? Yeah, Megan, what do you think? I could add 7 to both sides. I agree. So where I'm at, I got 5x is now greater than, help me out. Plus 16, good. Okay, now what do I want to do? Okay, subtract there. Before we do that, what property did we just use there? Which one? Yeah. Yeah, we're allowed to do that, right? Okay, so I got next one, subtract 3x. Yeah? Subtract 3x. Boom, what does that leave me with? 16. Okay, good. Now what am I going to do? I'm going to divide by 2. Now, dividing by 2 is the same thing as multiplying by what? By a half. So if I'm multiplying by a half is bigger than 0 or less than 0? It's bigger than 0, so do I need to reverse the direction of my inequality? No, I'm good to go. All right, I'm good to go. So I end up with x is greater than what? 8. Good. Now, how would I represent that on the number line? Put a 0. Put an 8 over here. Very good. Parenthesis. Notice it's going to the left, right? Or sorry, to the right. Then I'm going to open up that way. So give me an answer that would make this inequality true. Yeah. 9. Yeah, give me another one. Yes, sir. 8.01. Very good. Hey, is there a number between there and 8.01? How many numbers are between 8 and 8.01? Infinity is weird, huh? Yeah. Okay. I'm feeling pretty good. Give me a number that will not make that inequality true. Give me an easy number that will make that inequality true. 0, right? That's the easiest one right there, right? Okay, good. Okay, feeling good? Okay, let's step it up a little bit here. Let's make it a little more challenging. 1 minus 3 halves x greater than or equal to x minus 4. All right. Any thoughts?
You know the worst possible thing that could happen is if we just imaginary numbers into
All right. Comments, or not comments, suggestions about how we should do first. What do you do with that fraction in there? You want to keep it or you want to get rid of it? You want to clear it? All right, how want to clear it? Multiply by what? Multiply by 2. 2 is a positive number, right? We're still good there with inequality. So, distributive, what do I have? Anybody? 2 minus 3x greater than or equal to 2x minus 8. All right, so far so good. Okay, next idea. Who's got it? Add 8 to both sides. Okay, so I get 10 minus 3x greater than or equal to 2x. Next idea. Oh, okay, so 10 is greater than or equal to 5x. Are we okay there with that part? Divide by 5. Divide by 5. What do I have? 2 is greater than or equal to... Hey, is there another way I could say 2 is greater than or equal to x? Yes. X is less than or equal to 2. Okay. Anybody have any thoughts about which one they prefer and why? Or does it make a difference to you? Yes, what do you think? You want the bottom one? You want this one? Okay, is there a reason why you want that one? You don't know? Okay, yeah. What do you think? Yeah, go ahead.
Thank you.
You're welcome. All right, how would I graph this? Yes, what do you got?
So basically, I drew a graph with a 0 and a 2,
Mhm.
and then I would take the bracket
Mm-hmm.
and I placed it over the 2,
Mhm.
and then an arrow going that way,
Yep.
and then highlight it all.
And then highlight it all. Very good. Okay. The only suggestion that I give to students when we talk about inequalities, right? Both of these are logically equivalent, right? 2 is bigger than 1. 1 is less than or equal to 2, right? Those are the same statement, right? The only suggestion that I give is if you're dealing with inequalities, have your variable on the left, meaning your direction of your inequality will match the direction of your graph. That's something I would throw out there. Take it or leave it. Use it if you want to. But those two statements are exactly the same thing. All right? You guys feeling pretty good so far?
Yeah.
Okay, sweet. Let's talk about then a double inequality. All right. Double inequality, such as negative 6 less than or equal to 3x plus 2 less than 15. Okay, why do we say double inequality?
Because you have to do you have to do the problem 2 times with the 6 and the 3x plus 2 and then the 3x plus 2 and the 15, and then you have the 2 solutions which you graph.
Right. This is a marriage of two different inequalities, right? There's the one on the left that says negative 6 is less than or equal to 3x plus 2. Then there's the one on the right which says that 3x plus 2 is less than 15. All right. Do we have to break this up into 2 separate problems? No. The cool thing is that these are all related. We're allowed to solve this all together at the same time, so long as you provide, as long as you do all the rules the same, right? Okay. So what should we do first then, Megan? What do you think?
I think we should do -2.
Yeah, we're trying to isolate that x, right? So as long as you treat inequality, each inequality the same, you're good to go. All right, negative 6 minus 2. What do you got?
-8
Yeah.
is less than or equal to 3x, which is less than 13.
13. Very good. Okay. Next idea. Divide by 3. Yeah. 3 is bigger than 0. 3 is a positive number, so we're in the clear. Good. So 3 there. So on the number line, here we go. What 3 permutation do I need? And negative 8 thirds. 0, and then what? 13 over 3. And where is my information? Like, where do the answers lie? Where are they? Yeah, in between. Do I use parentheses or brackets?
Brackets, but it's closed.
Yep, whoops, thanks. Yeah. Everything in between there. So is this bounded or unbounded region? Because it's strictly less than 15? Not less than or equal to. Does that make sense? Okay. Strictly less than 15. Not less than or equal to. All right. Before we get into absolute value inequalities, tell me something that you know about absolute value. Let's access that prior knowledge. What do you got? Yeah, Jack.
So when you have absolute value in an inequality in an equation, you have to flip the sign.
Okay.
It's hard to explain it without writing out a physical
Sure.
equation that shows it.
Sure. I understand.
But
Yeah, I think that is part of it. What else do you know? What does mean? What does absolute value mean? What are we talking about? How? So we're talking about a distance, right? Okay. So now distances can never sort of be what?
Negative.
They can be negative. Okay. So we have to take all this information, and sum it up into a couple of rules and a couple of applications that we're going to use to help us solve absolute value inequalities, right? Okay. So let me give you the basics. Okay. That's what I call the setup here. Okay. If the absolute value of x is less than a. This is a less than statement, okay? I set these up in if-thens, okay? Then, what is happening here is we're producing a bounded region, okay? We want the distance to be less than a certain number of units away from 0, right? Or away from our x value. So, the way we set this up is negative a is less than x is less than positive a, all right? I just want you to put a big box around that for right now. All right, that's different than this statement here. If absolute value of x is greater than a, then we are producing two separate unbounded regions. And the setup is different. Then we have to produce two different unbounded regions because there are two regions that can be true to satisfy this inequality of a number being greater than a. So we have this. We have either x is greater than a or x is less than negative. That speaks to what you meant by flipping the signs, Jack. Is that what you meant?
Yeah.
Okay, right. The biggest mistake that students make is they set up a less than statement, a bounded region, as a greater than statement, two unbounded regions, or vice versa. So your goal is to not be that person. Does that make sense? Okay. So let's see if we can play with this a little bit here. So if we're talking absolute value of x minus 5 is strictly less than 2. All right. We're going to produce, or our value is going to be a bounded or an unbounded region from this. We want it to be less than 2 units. This is going to be a bounded region, right? So the way that we set this up is going to be different as if it were two unbounded regions. So how am I going to do it? Do I pick the first one or the second one? The first one, because I'm producing a bounded region. So I got negative 2. Strictly less than x minus 5 less than 2. Right, now, check it out. We're back to solving a double inequality. Have we already dealt with these today? Yes. So this looks familiar, right? So see how these things build on each other? All right, I'm going to add 5 everywhere. I'm going to come up with, what do I have? Help me out. 3. Less than 7. Okay, let's explore this here. Here's my number line, okay? Here's 0, here's 3, here's 7. Where does my solution set lie? Between 3 and 7, okay? So do I use parentheses right here? Okay, so any number in there, right, will deliver a true statement for my absolute value inequality, right? What number will not deliver a true statement for my absolute value inequality? 2, yeah, well, yeah, absolutely. Test it, right? 2 minus 5, how much? Absolute value of negative 3. 3, is 3 less than 2? No, absolutely not, right? That's not what that stands. However, any number in that region will produce a true statement for my inequality. And notice that my statement is a bounded region. How do you feel about that? You feel pretty good? Okay, that is in contrast to, how about this? Absolute value, let's see, B, this was A. Absolute value of x plus 3 is greater than or equal to 7. I have a greater than statement. Okay? So I'm going to have a lot of possible answers for this. I'm producing two separate unbounded regions. All right, what's the setup going to be then? X plus 3 greater than or equal to 7? Or what's the other one?
X plus 3 is less than or equal to -7.
Then equal to -7. Yes, very good. Okay, that's the proper setup, and this is going to produce two separate regions which will combine into a graph at the end, right? I don't know if they're doing that there. All right, so this means x is going to be greater than or equal to what? 4, right? Or x is going to be what? Less than or equal to -10. Okay, now let's interpret number line. Check it out. Okay, here's 0. Here's 4. Here's -10. All right. Am I using parentheses brackets in this context? Brackets. Good. All right. Go to the left. My region. Go to the right. My region. So notice I have two separate unbounded. Any number to the left of -10, or including 10, or simultaneously any number to the right of 4, including 4, will deliver a true statement to my absolute value inequality. So the biggest mistake people make is they set them up the wrong way. They use a less than for a greater than and vice versa. Does that make sense?
Yes, if you have time.
Yeah, we have time. So I'm going to pause this. Here was a try. I forgot what the answer was. Hopefully you guys did that and checked it. Nice job.